Now let's look at method 2. Under method 2, we are going to use the table what method. So here, what do we do here? We have our year. Then we look at the cash inflow for project A. We look at the cash inflow for project B. And then we look at what we call discount factor. Discount factor. And then we look at the present value of project A. Then we look at the present value of project B. Yes, in that order. Something like this. Then we have our total. You can write a total here, or you can choose to leave it. Either ways, you are going to still get your correct answer. Okay, so what do we have here? When you look at our initial investment, Sikana Obabe spending, initial investment, we put 0 here. That is, say 1 year in buy. Or say after 1 year, Sika Beni Benya. 2 years, and sanity. So yeah, no, the 0 here represents our initial cash outlay. So the initial cash outlay for project A, Sika ya one you spending on project A, no, 10,000. So introduce bracket. Why do we introduce bracket? It's no, Sika ekwa bonting. Remember, I said when you see bracket meaning negative. Meaning if you are coming to add, we'll see this one as negative. Okay. Project B, we are using the same 10,000. Now, what will be our discount factor? In our previous lesson, we treated how to calculate a discount factor. And we said, when we say discount factor, this is the formula for discount factor. We said it's 1 over 1 plus r raised to the power n. You see, it's just like this. A figure here, but here is 1. Then that is it. So 1 over 1 plus r, where r is the 15%. Remember, 15% means 0.05. 0.15, sorry. Raised to the power the number of years, which is 0. 0 years. So, 1 plus 0.15 is just 1.15. Raise the power 0. And in mathematics, if I put all of this in calculator, my answer is 1. Why? Because in mathematics, we say any number raised to the power 0 is 1. So our discount factor here is 1. How do we find the present value? To find your present value, you multiply your discount factor by the cash inflows. So the present value of A is 1 times this, which will give you still 10,000, but since it's negative, we put the bracket here. The present value of project B is still 1 times the figure you see here, which is 10,000, but since it's negative, we have it here like this. All right. Now year 1. Year 1, project A, 2,500. And then year 2, 3,750. Now, what will be our discount factor for year 2? So, to find the discount factor for year 2, it's just the same thing. You'll do it somewhere and come and write the figure over there. 1 over 1.15. You know where we got our 1.15? It's 1 plus 0.15. That is the 15%. All raised to the power the number of year, which is 1 year. So, we have 1 over 1.15, and that will give us 1 over 1.15 raised to the power 1, and that will give us 0.8696 4 decimal place. That is it. Now we multiply this discount factor with this by this. So we have 2,500 times 0.8696, and that will give us 2174. Then we multiply this by this 0.8696 times 3750, and that will give us 3261. So we are done with year 1. Okay, now let's come to year 2. So under year 2, what do we have? 2,000 for this and 3,750. Now we need to calculate the discount factor for year 2. So for year 2, you know, the same approach, 1 over 1.15 raised to the power what? 2. So on our calculator, 1 over bracket open, 1.15 bracket close raised to the power 2. And that will give us 0.7561. So this discount factor times 2,000, 0.7561 times 2,000, and that will give us 1512.2. And then the same thing, 0.7561 times this our 3,750, and that will give us 2835.38 to 2 decimal place. It's 375, but you run it. Then year 3. Under year 3, we have 1875. And then we have 2,500. So what is our discount factor for year 3? You see that our discount factor for year 3 is going to be 1 over 1.15, which is the power what? 3. So bracket, we have our fraction 1.15 bracket close raised to the power 3. And that will give us 0.6575. So 0.6575 times 1875. And that will give us 1232.81. Then when we come here, we have our 0.6575 times 2,500. And that will give us 1643.75. Then we come to 4. So we have 1250 here. We have 2250. So what will be our discount factor? So do it yourself and then put your figure there. Let's all do it. So I have 1.15 raised to the power 4. And I have 0.5718. So 0.5718 times 1250. And that will give me 1714.5. Then when we come here, 2250 times 0.5718 will give us 1286.55. Then year 5. So under year 5, we have 3,000. We have here as 3,000. And then the cash inflow for project B, 2250. So we look for the discount factor for the 5th year, meaning raise the power what? 5. So we have 1.15 raise the power 5. And that will give us 0.4972. So 0.4972 times 3,000. And that will give you 1419.6. Then 0.474972 times 2250 will give us 1118.7. So when we are done, what do we do? You see these figures we have here, we add this to this to this to this to this minus this because this is negative. So let's start from here. 1491 0.6 plus 714.75 plus 1232.81 plus 1512.2 plus 2174. Then this is negative, so minus 10,000. And that will give us negative, is negative, so we put it in a bracket. Negative 2874.64. You see, approximately 2874 point. Now, the difference between the decimal does not matter because here we are running numbers. You see, all of these ones are numbers that we are running. But when you look at the whole number, it's just the same thing. Now, let's do same for this. So we add 111.8.7 plus 1286.55 plus 1643.75 plus 2835.38 plus 3261 minus 10,000. And that will give us positive 145.38, just like you are seeing here. Positive 145.29. So you see the 145 was an approximated what figure. That is what we are having here. So this figure we have here is what we call our net present what value for project what A and then project what B. So we go by the same. Since project A has a negative net present value, while project B has a positive what net present value, the investor should invest in what project what B. So we have method 1. This is our method 1. And then we have method 2. So you can use your discretion to select any of the methods, either to use a table method or to go by this.